Hi, everyone. Thank you for joining us today with Africa Fire Mission. We're excited to host you and to have Dr. Walls with us today as well. He'll be introducing himself, but I think this will be a fantastic presentation and very relevant to the work that you do. As you all know, the meeting is recorded, so you'll be able to access the materials after the training on our website and also on YouTube. And so we look forward to you referring to those materials. I'll post any links in the chat. Because this is a 1-hour training, we do ask that you introduce yourselves in the chat so we can just network with each other a little bit here. And also feel free to ask questions throughout the presentation in the chat. Today, Jose will get us started with a few words of encouragement, and we will continue on with the training.
All right. Thank you so much, Nancy, for having me. Thank you so much, Dr. Richard Walls, for joining us. And thank you, everyone, for finding time to come and join us today. Today, we are on day 75 of the year. Can you believe it? We just are sailing through like crazy, and we thank God for that and taking us through, giving us life as we go through. So today in our book of encouragement, 90 days of encouragement, overhauling your faith, yeah? And I'll jump into day number 75. The topic is fully equipped. It is written by Craig Dark, President Missionary of FCF International, yeah? And I will read 2 Timothy chapter 3 from verse 10 to 17. Encouragement of the day. All scripture is breathed out by God and profitable for teaching, for reproof, for correction, and for training in righteousness, that the man of God may be complete, equipped for every good work. That's from 2 Timothy verse 3, chapter 3, verse 16 to 17. So, President Craig Dark writes, "We are spoiled in the fire service here in America. I just came back from a fire show from out on the West Coast, and I was able to walk around and look at all of the new fire trucks that the manufacturers are selling. They are filled with all sorts of firefighting equipment. Fire trucks have every type of couplings for connecting hose, tools for breaking apart things, ladders for getting into windows, and specialized equipment for all types of emergencies. I really enjoyed looking at all of the new equipment being offered to today's first responders. One of the manufacturers there was selling the fire trucks fully equipped, ready for immediate use. I'm thankful that God has not left us here to figure out on our own. God has given us the Bible in order to help us get through life. We are told that the Bible is God-breathed or God-breathed and is able to help the Christian firefighter with any circumstance that he or she comes across. The problem is not all Christian firefighters are reading and studying their Bibles. They may own one, but rarely do they pull it down from the shelf and read it. We don't buy a fire truck without equipment, leaving it parked in the station. Why then do we buy a Bible and leave it in the shelf? In 2 Timothy, we learn that the Bible is profitable for all sorts of things for the Christian firefighter. We need to regularly read and study what it says. It is also profitable to memorize the word of God in order to be prepared for life. How about you? Are you fully equipped? Lord, help me to be ready and study the Bible today that I might be fully equipped for life. That is today's encouragement. And even as we go in the fire service, please let's all remember to read our Bible. I will pray and we begin. Let's pray. Dear Heavenly Father, Thank you for today's lesson. Thank you for Richard Walls. Thank you that you have enabled him to come here and take up the class. We ask you that you guide us and give us a good connection as we start the class. I pray this all, trusting and believing in Jesus' name. Amen. Dr. Richard Walls, please take it away.
Okay, good afternoon, good morning, depending on wherever in the world you are. It's fantastic to be with you all today. Firstly, can someone tell me if you still see my screen? I hope, Nancy,
You're
Jose?
there.
Yes,
You're there.
Great. Good. All right, so let's keep going. But thank you for this time. It's great to be here and share with you. And I'm going to be presenting today a fire safety engineering guideline for informal settlements. So this is the background is this is actually a book we have just written and released. So that is it. There's on the screen, and there is a download on the screen, a link. You can actually download it free of charge. Now it's not as good as the book that Jose was just reading from, but hopefully it'll be useful in some specific ways in terms of life and service in what you're doing. So in some ways, hopefully it'll be a blessing what's been produced, but we will just be running through some of it. But so as said, I'm Richard Walls. I'm from Stellenbosch University in South Africa, and going to be talking on the aspect of fire safety engineering for informal settlements. Now, I actually run a research group here in South Africa. We've got almost 20 researchers working on different topics, about 8 or 9 PhDs and about the same amount of master's students, 1 or 2 postdocs. Numbers are constantly fluctuating. We've just developing fire labs and facilities, and been working for the last about 5 years on informal settlement fire safety, amongst various other things, structural design and all sorts of things. So going to be looking at some of the work, but it's not just to dive into here's the solutions, because I think you know more about solutions than anyone else and know how difficult this problem is. So what I'm rather going to be doing up front is actually going into the background and the research we've been doing, and we've been burning down a lot of stuff. I think I've burnt down about 70 informal settlement dwellings myself. So I'm a bit of an arsonist. I like destroying things and then figuring out how on earth we describe it. So with maths. But as an overview to the book, so this, to know what is in it, because I'm not going to cover a lot of it. It's 140 pages. And just, sorry, as a background, we are busy producing training videos based on this book, which will also be released free of charge, along with a bunch of brochures. So this is quite a hefty work. If you can see my screen, there's a copy of it in front of me. And so you can download it, get hold of it. Print it if you like, but electronically. But as I said, we're using sort of a lighter version, a bunch of training videos that'll be available soon. So we first go to introduction, informal settlement context, understanding fire safety design, informal settlement fire incident to take people through the timeline, case study, 27 Imizamo Yetu. So that was a big disaster in South Africa, about 10,000 people left homeless. And then the main work actually looks at all the different interventions. Half of it is just to say, please don't use the following things that you've been spending money on, but there are various others, promoting things. Then there's fire safety for backyard dwellings in formal housing areas. So that's, we have a lot of formal dwellings with informal dwellings in the back. You may use the word shacks. There are various words. Some people like or dislike various terms. So I do understand it's quite sensitive. And then conclusions and the way forward. So just as a background, our current population is around about 7.5 billion. In the next 80 years, we're going to go to about 11.2 billion. And we currently have about 54% of the world in urban populations. But lower income countries where most of us are all based, we're going to move from 30 to 39% or 48 to 57. So if you take the population growth and rural-urban migration, we're probably going to see 1 billion people moving to informal settlements in Africa, depending on how you run the numbers. But our informal settlements are going to grow rapidly. They're going to double or triple in the coming decades. So the developing world is experiencing the growth of low-income settlements, especially in countries in Africa, Asia, South America, and city infrastructure and housing is often insufficient. So here is an area in Cape Town, and you'll see the timestamp, July 2014. And just a couple of months later, an entire settlement can spring up. We have a land invasion, and then people move in, and it rapidly densifies. So in the space of a few years, we go from nothing to quite a dense area. And I'm sure many of you have seen this in your countries as well. Here is Kaimandi. This I can actually see from my university. It's just on the outskirts of town. So in the space of a couple of months, entire sections have sprung up. And since 2017, there's actually been quite a densification up on the hill. Another couple of areas have sprung up. So these areas are certainly growing rapidly, and a major, major challenge. So let's look at how dwellings burn. And at least what's quite fun talking to firefighters is, I think you understand a lot of this, is we started with conducting experiments just on single dwellings. And what is, I suppose, useful, but maybe not unexpected, is that what you see with these dwellings is fairly typical fire dynamic behavior. There's ignition, there's a growth phase, you've got a localized fire, you've got a hot layer that builds up at the roof, and then you head to flashover in the dwellings. And then from flashover, 1,000 degrees Celsius, etc. Flames emerging from the windows, etc., etc. And so we can describe this relatively well. We can, with computers, mathematics, whatever it is, actually predict the temperatures, predict the fire behavior with reasonable certainty now, if we know what's happening inside. Ignition, far more difficult. So we also started thinking, now, what happens when there are multiple dwellings and different types of cladding? So here are 3 timber dwellings, and at the top, I'm just going to stop it, you will see the temperature. So the first one, we ignited some timber cribs. You'll see the temperature at the roof is now about 100 degrees Celsius, and it's slowly starting to build up. Once there's enough hot gases, then the cladding on the wall ignites. We have flashover in the dwelling. And then it rapidly spreads through to the dwelling next door. We actually had a fire tornado, little fire whirlwind developing here, 2 to 3 meter diameter. Second one spread, hot layer drops, second dwelling ignited, spreads to the third dwelling ignites. Once it gets into the cladding, it's always, once it finds the combustible lining, that's always when things start going wrong. Even though it was timber, it had a little bit of a delay. Up there, it got the cladding and gone. And we were getting temperatures of between 1,000 and 1,200 degrees Celsius in this experiment. So very intense, very rapid spread, very high heat release rates. And then eventually it just totally burnt out. So it was burning as fast as it could. Very, very intense. At 16 meters, we had items starting to smoke, so incredible radiation coming from it. It is much lower when you have non-combustible cladding. If you have steel cladding or just corrugated iron, it's a far less intense fire, but that. We can start predicting that and predicting flashover and spread. This is actually a computational fluid dynamics model looking at spread from one to the next and saying, when would each ignite and how would it behave? On their own, these are not particularly useful. It's like, well, great, you have a very accurate model of something that's highly uncertain. But at least what's useful is it can start helping us to predict spread. And I won't show it in this presentation, but models for predicting spread through entire settlement are starting to be developed. And so from there, we actually got onto then 20 dwellings. So this is a full-scale experiment. This is 20 dwellings. It's 4 by 5. We ignite the 4 dwellings at the bottom. And what happens is, this is after about a minute after ignition. The first 4 caught at the bottom of the screen, and then it's spread onto the second line of dwellings at about 2 minutes. And then from here, spreads to the third line. And you'll see by the end of the experiment, and it's about 5 minutes and all 20 homes were on fire. There was a bit of a wind blowing, about 20 to 25 kilometers an hour, but there's far stronger winds that blow in our ear. But spread, and then it came straight through. I mean, it hit that last line of dwellings. And the normal response time is way in excess of this. So if you have this sort of starting, by this stage, maybe the fire department's on its way if someone's dialed the right number. And it was just useful to show the intensity and to evaluate interventions against this, because many people in South Africa are proposing all sorts of suppression products and paints and boards and you name it. They're trying to to sell it to government or municipalities or fire departments to solve the problem, and they think it's magically going to take it away. But not a lot of testing has been done to evaluate informal settlement solutions against real life experiments. So that's what we've been doing to try quantify what do we actually need to do to slow these things down or stop them. But just coming back to the video here, after about 17 minutes, there was pretty much nothing left. I mean, the entire settlement was totally gutted. What was actually kind of funny is the last dwelling standing, it had 4 dwellings around it with timber on the side, and it burned so ferociously that it didn't allow oxygen into the one in the middle of it. So we actually oxygen starved that one. But here you can see a side view coming all the way through. There's us watching. Months and months of work, and 5 minutes later, our experiment was long gone. So we have, this is actually on YouTube. I forgot to put the link up, but this is public knowledge, and it's in a journal publication that's in the public domain as well. So all this data is publicly available. And yeah, so then you'll just see a front view pop up now where we then ignited the first lines of dwellings. And what's important to see is the ignitions that occur, because many people will often try protect the walls. But what you actually find is with the intensity, if there's any hole anywhere, the fire will slip through. Coming along, just going to quickly run through another sort of basis, another case study from which we're trying to start basing data on fire spread and behavior, etc. This is the Imizamo Year 2 fire in 2017, 2,197 structures destroyed, 4 fatalities, around 10,000 homeless, extensive damage to the local infrastructure, about 10 million rands worth of damage. It's what, about $8 million? I think it's less. Our currency's gone down a lot. $7 or $6 million worth of damage. And so, but it was a lot of damage caused to the area. 176 firefighters, 2 helicopters, 13.5 hours fighting, and 19 acres burnt. So the fire started there and then burnt up the hill, and the wind actually turned and burnt it down the hill after that. And so you could see flames 2, 3, 4 stories high that were affecting the area. And this also is in a journal paper, so this is also publicly available knowledge. If in doubt, you can email me and we can send it through, or contact Nancy and we can pass these papers on to you. So the paper started there. And just as a matter of interest, this is about 40,000 people in this sort of area. And right across the road is a very wealthy area in called Hout Bay. Now, so here the fire started. It was just at about 7:30. It took quite a few hours to spread from the initial position all the way through, because there was a lot of firefighting effort. So it was slowed, speeded up, slowed, speeded up. But what happens is it hit a line of blue gums, and then everything just went pear-shaped after that. So the first area, the first sort of 7.5 hours, or 8.5 hours, there was about 1 home a minute being lost. But then it hit a line of eucalyptus or blue gum and then blew down the hill. And then you're about 9 homes a minute being lost after that, for a period of roughly 2 hours. And then then it started slowing down as the firefighting operation started to take effect. They even had helicopters bombing homes, which is not normal. And then eventually at about 1 o'clock, they managed to stop the fire. So it was incredibly intense fire and a lot of damage done. So I'm just going to lastly swap to something. I'm going to use it very briefly just to show what happens in a real life incident. Oh, sorry, this is now footage. Unfortunately, this I can't share with you, but I have got this in a private file. So this is actually another analysis that is the paper we can share. There is a paper on this. I can't share the video, but I can share the paper. This is where about 40 homes got destroyed. And what's interesting to see is the initial community response, putting firefighting efforts early on. But it's also, as you probably have the same there, is that it actually was a gas canister detonation in the middle of it. So it hit probably an LPG canister. It was about now a little bit further on, and it ended up spreading rapidly. But in this period of time, 41 homes got destroyed. And what's useful is we got to see data from start to finish. What did people do? How did they respond? Where did they go? And how did they intervene? How did they evacuate, et cetera, et cetera? And from that, it's useful to then evaluate strategies. Again, there we go. You'll see a canister detonation. And shortly before that, there were people on roofs fighting the fire. After the detonation, you can see everyone just basically runs away. And but there was still a lot of people in the area. So coming back to this, what's important from all those is trying to define how do homes ignite. And at least, I suppose this is preaching to the converted with people in the room. You know more about fire than most of the people I chat to. Often this work is for decision makers, NGOs, municipalities, etc. And trying to evaluate how do homes ignite against what they're trying to do to stop it. And the main forms of ignition, flame impingement. So we've got openings, and then the flames come, and the flames find any holes. And often it's the small holes in walls or unsealed spaces between walls and roofs that allow fire in. And people spend money protecting the wall and they don't do fire stopping, and then you've pretty much wasted your time. It's often just sealing the gaps and taking the newspaper shoved into holes out that can make a bigger difference than putting a fireboard on the side, because the newspaper stuck in the corner sucks the fire and ignites the curtain, and that's that. Radiation can ignite homes over about 3 to 5 meters, depending on the intensity of the radiation, and it can ignite products such as plastics, woods, etc. Especially when you've got thin materials, plastics, newspaper, etc. They ignite far more quickly. And then also branding and spotting. So you can have flaming brands. These can be travel 5, 10, 15, 20, 50 meters, land and cause spot fire. So often people think, all right, I'm going to put a firewall up or a bit of a divide, and then the fire won't spread. But we have seen cases where a spot fire may develop at 30 or 50 meters away. We have no data on it at the moment. It's more just stories from firefighters, but at least does show that you have to be very careful when the wind is blowing, which it does in Cape Town very much. It can jump most things, and often people's proposals of putting some sort of fire barrier, it may be good, it may slow it down, they don't realize that the fire can jump it. And so any intervention may have to look at it. And also people then will try to retrofit the homes and make it more fire resistant. But at the end of the day, the door and the window is always your weak spot. So if you've got flame impingement up against the window will crack, the curtains will ignite, and you've got a path into the home. So even just closing your doors and windows upon evacuation helps. So time is of the essence. And one major problem we have in South Africa is people, firstly, I think, don't understand how complex it is getting to these events. And secondly, who to phone. We have a bit of a problem that often they phone the wrong number. They'll phone the police rather than the fire department. So that hopefully will be addressed soon. But when people see how it's quite a process from time you observe the fire to the time someone actually does something about it, or they detect it, then they notify their community and the fire department, who've then got to alert the responders leave the fire department. And what's a bit different from this sort of flow diagram to a normal one is they can arrive at the informal settlement in a fire truck, but often then it takes a while from the informal settlement to the actual home where the fire is burning. And then from the home, and then they've got to set up, put it out, etc. And all this while the fire is growing. So any few minutes, maybe another 3, 5, 10, 20 homes that are affected. They've suppressed the fire, so the orange fire, and then finally they can, then the mopping operations and support organizations getting involved. So the more we can cut down this timeline, the better. Anything that reduces the time required helps. But this is especially difficult when you need police escorts, and often we have live electrical connections that also need to be turned off. So the municipality's got to come out, and all these things delay it. So I think in terms of time, if you want to design something, there are design process, qualitative design review, quantitative analysis, assessment against criteria. And there's a design process to say, would a certain products work, and how to evaluate an overall strategy. And so in this, a flowcharts have been produced to help guide people through, especially municipalities, decision makers, higher level things, to analyze the context, review the settlement layout, establish fire safety objectives, identify hazards, establish fire scenarios, acceptance criteria, and then trial, fire, and social scenarios, and then to run through this. We don't have time to look at all those things, but there are ways and means of putting together a picture of what is my community, what do I need to do, and what is success, what is failure, and then how do I compare it against that? And also, where the experiments that I showed you earlier is trial, fire, and social scenarios. A lot of the solutions we see trialed in South Africa are less effective because they don't understand fire dynamics and ignition and spread and all the intensities and such. And I'll show you some of those. Ultimately, we propose a bit of a framework in that there is no magic solution. Unfortunately, one thing, I spend a lot of time presenting to Department of Human Settlements and various other groups, and you'll arrive there and they expect you to have this magic wand to give us a gadget that can take the problem away, and it doesn't exist. And as I said, this is preaching to the converted here. We need a range of things. And you may have different names for these or different classifications, that's fine, but it's just the concept. We need active fire protection, suppression, detection, etc. That's you guys doing a fantastic job. Passive fire protection, construction products, area layout, how do we reduce the speed of spread? And then how do we do fire prevention, risk of ignition, which I know many of you are also involved in these as well. So how do we put the fire out? How do we stop it from starting in the first place? And how do we prevent it from spreading? And that's integrated fire safety. And we need community awareness, response engagement, and all of these. And I think what problem we see in South Africa is often a municipality will target one. They will then put money into buying more fire trucks, which is great. But if we're not doing fire prevention, that's a problem. Or they will buy some passive protection product to put on people's walls or to try and improve home construction. But to be perfectly honest, often those are less effective, or they're just too many fires starting and not enough fire response. So in the work, what we do is we map out a lot of different interventions. These are just some of them, whether it be reblocking, boards, paints, improved construction materials, access, electrification, first aid, community response, water, etc., fire department, buckets, extinguishers, and then just look at what's the pros, what's the cons. As I said, no magic solutions, but just looking at what if I issue a fire extinguisher, great, 1 9-kilogram DCP may do the job, you might need a second one, but does it need maintenance? Do you know where it is? What's the cost of it? All those sorts of things. So we just take it through. That's why the book's so long, because they just takes through a lot of interventions and evaluating. So here are some of the things we evaluate. For instance, fire departments, including strategies, training, mobile firefighting units, area support, fire department, improving relations, etc. Looking at a national unified emergency number, that's big for South Africa. It may be less of a deal where you are. Water hydrant infrastructure, suppression products, and then you get blankets, bucket brigades, dry firefighting. Then we have smoke and fire alarms, community response teams, reblocking, firewalls, roads, construction materials, retrofitting of homes, escape, mapping, electrification, fire safety, improved cooking, education, medical training. So those are some of them. So just to summarize these, just to briefly go through some of these items. Firstly, our main problem is know the phone number, know the local fire department number. People are regularly phoning the police, and that's probably the biggest thing. If we could get right, and that people just phone the fire department. And the problem is it's a 10-digit number, Cape Town 021 480 7700. It's too long. Hopefully, as I said, that'll be addressed soon. They're doing, the city of Cape Town is doing a great job, and Winelands and various others to promote it, but it's still difficult. What techniques can be used? Access for fire trucks. These are sort of the questions that can be asked. Can you use dry firefighting methods? We used to do that back in the day, but it's a bit dangerous now, driving trucks over things, and you can squash people. So community response teams. So those, I think many of you are aware, so I'll discuss some of the interventions that are currently being tried and where they work and don't work. A while back, there was a work on intumescent paints. Now, intumescent paint is a fire retardant paint you put on a home, and it basically expands and provides a char layer. And so you commonly use it in structural fire design for high-rise buildings and tunnels and all sorts of places. It's, as a product, it's often quite efficient. But for informal settlements, it just doesn't work, because this is to protect structural elements, not to prevent ignition. If you put this on, it doesn't necessarily mean that you're going to have reduced ignition, because the impinging flames will still fire the home. Even if the paint activates, chances are it's not going to do much. Same thing with boardings. People put on boards and they don't fire stop it. Fire safety kits are often issued after disasters. So we do have, when homes are burnt down, they will issue then sheeting and timber, etc. With recent budget cuts, that stopped happening. This at least helped with relief efforts, and it helped put people back on their feet, but it didn't reduce the fire risk. The fire risk remained identical. Various educational programs, which I'm not going to have time to go into, but looking at municipal infrastructure as well, looking at how this influences and doesn't influence things. For instance, this was the imizamo yetu, the disaster. So what happened is, for instance, these were hydrant positions, but one of these hydrants was not found during firefighter operations. It was possibly the resident's home was built over it, so they may have been using it for domestic water supply. Then this hydrant here was used extensively. They had 3 lines going off of it, but it had insufficient pressure for the multiple lines. They had to keep swapping between the 3 different lines. You didn't have 3 teams operating, you only had 1 at a time because of water restrictions in the area. So main access road, very congested, and often these infrastructure problems, which I understand many of you may not have the authority to deal with infrastructure, but the infrastructure makes a big difference. And the road was narrow, limited access. And so lobbying for decent infrastructure, road access, makes a big difference. And people build into this roadway, and it's just a general mess. Trying to get people in and out of this area during a disaster. Electrification. Now, electrification does help. We are seeing numbers that when suburbs are electrified, it is assisting, but I think sometimes people think that it's a magic quick fix, and that once homes are electrified, all the problem goes away. And you see everywhere in the world, and in America, I mean, you've got electrified homes and you still have homes burning down. One of the problems we have is illegal connections. Either the people will tie into existing infrastructure. So you can see all these lower lines are electrical connections. And so this becomes a mess. And the fire departments can get electrocuted by it. Or when the fire truck arrives, they actually just can't get their truck underneath. So they have to either break the lines, which is risky, or do various things. So it's a major problem. They often just can't get in because these electrification lines. I do support electrification in general. It is good, and it helps reduce risk and improves quality of life. But I think often decision makers aren't aware of the problems, and we are seeing quite a lot of electrical overloading. A line comes into people, as we often have electrical problems leading to other questions. Cooking, lighting, heating. The main question is, what could we do to improve the way people use energy for daily living? And there are various things. There are safer cooking stoves, there are solar lights, there are all sorts of different interventions that people are doing for cooking, lighting, and heating. All of them have their place. I would encourage all of them normally. The biggest challenges we see often, for instance, the fancier cook stoves need special fuels, and then it gets too expensive, so they get abandoned. Paraffin stoves, I mean, this is not a safe one. Paraffin stoves are a major challenge for us. People knock them over, and then it's a very rapidly spreading fire after that. We do have codes of practice to regulate them, but it's questionable to the extent those are being done. As it's solar lights, various other technological interventions, often they just either don't last, people sell them, they just break, various things happen. So those are ongoing challenges. So cooking, lighting, heating, major source of numerous fires, but they all have their own problems. And I think that's where people don't realize is that the challenges associated with roll them out. There has been a certain amount of success with reblocking in South Africa. For instance, you have a settlement, here's Mshiniwami, and the people then work with a NGO or municipality, and then they reorder themselves into a blocked arrangement. This is good for providing access, layouts, a bit more flow, etc. It's quite time consuming, it's quite resource consuming, and it needs a lot of community buy-in. This does not happen overnight, and it requires the roads people and the infrastructure people and all sorts of people sitting around the table and agreeing on, and community investment. So a lot of people are pushing this, and I'm not against it, but I think also people don't realize how much work they are and what Yeah, and this is becoming more policy in South Africa, but it's not easy and it is a slow. So suppression systems are you may find interesting, at least in terms of evaluating things. We have developed a benchmark test that has been developed to evaluate different fire suppression interventions against each other. This being done for fully developed post flashover fires. The idea is not to produce a SABS, NFPA, BS, whatever code of standard you have, but rather benchmarking processing carried at a fire station in South Africa or abroad. So we basically just built a dwelling. We have a certain fuel load and then we burnt it down. So as I said, I like arson, I burn things down. And then we said, how can we put it out? And we put it out in various different ways. Standard firefighting hose, nozzle aspirated foam system, compressed air foam system. So that would all be the top three is the fire department stuff. Then we used bucket brigade, multi-bucket. So we have a bunch of buckets all at once, or we have a single bucket one at a time. We use dry chemical powder, proprietary throwing products, a liquid bottle and a DCP, a dry chemical powder sphere. So then we measured the temperature and we said, all right, from the time we apply our intervention, how long does it take to drop the temperature to basically extinguishment level? And this is a ceiling temperature. So even when the fire is extinguished, you can have hot gases, steam at the roof. And just we follow this curve, we measure the temperature along the way and we see, is what we're doing influencing the results? So it's mainly from post-flashover to give or take extinguishment. So standard firefighting hose, as you know, very fast temperature drop and extinguishment, amount of water required higher than the next two tests. So when we had nozzle aspirated foam system, fast temperature drop, less water required. It did need a little bit more technical application, a little bit more technical setup in terms of the operation of the foam addition. Then compressed air foam system. This is starting to become more common in South Africa. Very fast temperature drop and extinguishment, much less water required. It is an expensive initial outlay, more experienced operator required. You can get smaller units, may be effective on buckies. The Americans, I think, would probably call this a truck or utility vehicle. There are various names for a sort of smaller vehicle that at least can get in there. And with the compressed air foam systems, you get quite a high expansion, so it can blanket a lot more, so it can get there and then do more. But you do need quite a bit more money outlay, and it only has a couple of 100 liters worth of water. At least that is expansion, so you have much more effect. So they can get in and out, but it's still the balance is this going to be better than a truck? And it depends. So there's a bit of a debate. Bucket brigades, good old buckets. I like buckets. In one test, 9 buckets required to fully extinguish fire, meaning total water used significantly than a hose, but it took longer. It's simple and effective. A couple of 8 or 10 or 12 liter buckets is, to be perfectly honest, often the best way. We tried it in 2 different ways, not a huge difference in results, but just get the wet on the red as fast as possible. And it requires a lot less water than a hose, but obviously the hoses make sure everything is dead. I mean, it kills it and there's no reignition, where reignition is much more likely with buckets. Dry chemical powder fire extinguisher, 1.9 kilogram extinguisher was almost enough to put the fire out, but required a second DCP. Typically effective, more than expensive than buckets. And one of the problems we see is people issue these and don't realize that A, they can get stolen, B, I believe they even get used for drugs somehow. I'm not quite sure, but then they require ongoing maintenance, etc. So often this rollout is done not thinking about all those sorts of issues. Then we tried the magic sort of product. So here is a product that was being sold to municipalities to extinguish fire, throw directly into fire. It's about 1/2 liter. And so we used 24 of these units. It did not extinguish the fire. What happens is with the smaller units, when you throw them into the fire, it may suppress the fire locally in a 1/2 meter area in the corner. But the temperature in the dwelling is above spontaneous ignition temperature. So the fire comes straight back. So the water gets evaporated, whatever product is in it does very little damage. So you can't apply cooling agent fast enough. I literally I threw 24 of these and I was quite proud. I didn't miss once. And often, let's say, now you're panicking, so normally you may miss. And these were about 300 or 400 Rand each. So it was about 10,000 Rand, which is what, about $600-700 worth of product. And it didn't slow it down. See, so also we tried dry chemical powder extinguisher ball. So this is a ball with a DCP inside. It's got a fuse. You throw it into the fire. We threw 10 of those at about 600 Rand each, so about 6,000 Rand, which is about $400. It did not extinguish the fire. Burning rate slightly reduced. Test stopped with water. Units not susceptible for large fires. Easy to miss, may not go off, so we are cautious of using those. They may be suitable, these products, for small fires. If you throw them accurately at the fire, they may be working, but on larger fires, typically not suitable. So summary of suppression: standard firefighting equipment effective, CAFs and potentially use less water, upfront cost barrier. Buckets surprisingly effective, good old buckets. DCP effective, must be maintained, easily available. Proprietary products not suitable for post flashover. And the problem is often the mayor sees a great intervention and goes, wow, and he buys, you know, a whole bunch of these sort of proprietary products, and then they're just not as effective as people were hoping them to be, and they're in the cupboard when people need them. And so we advocate that testing must become a part of decision making. And then further along than that, there's smoke alarm testing, and we've been involved with a rollout of about somewhere 5,000 to 10,000 smoke alarms. Well, we did the upfront initial testing, but then our provincial disaster management, they've been leading the main charge on this. And we built some dwellings and started testing activation in an informal dwelling and saying, would this work? Because there are various devices that people are providing, either photoelectric smoke alarms or rate of rise fire alarms. And we did nuisance alarm tests and various other tests. We are hoping to win a grant soon that we can do quite extensive testing on this. This was really preliminary work. Good results, but it was still preliminary. As it was only about 10 small tests. You need to do like 50 or 100 tests to really be useful. Activation times measured in flaming and smoldering tests. For instance, the carbon monoxide and rate of rise generally did not activate at all. They require quite a significant signature before they go off, which is concern for flaming fires. Data analysis needs to actually progress, and we'll focus it further. But just to comment on those, what we do see is that the rate of rise devices, they do not go at all in smoldering fires, as is common knowledge. The smoke alarms, however, the photoelectrics, they're much better at detecting smoke, and so they will detect a smoldering fire. The biggest challenge was we're seeing quite extensive nuisance alarms for them. The environments are quite noisy, dusty, bugs get into them, etc. So they experience quite a lot of nuisance alarms, which is a problem. They've had a couple of large rollouts, and nuisance alarms have been problematic. We're hoping to find a simple way of modifying it. We actually have some ideas how to do it, but we will wait to see whether we can do that or not. And so last couple of things, as I said, backyard dwellings. I don't know in your countries whether you get these or not, but you have a formal home and then backyarders. So you will build 1, 2, 3. They sometimes call the shack farming. There are a couple of things that we're seeing with these. Backyard dwellings are often highly flammable with high fuel loads. Informal electrical connections to the main house are high risk. We're seeing more electrical fires starting. Adjacent formal homes have higher fire risk due to the presence of the backyard dwellings. Fence or formal houses and other backyard structures make evacuation difficult. What you see is that there's a higher death rate per incident in backyard dwellings than there is in informal settlements. In formal settlements, people can evacuate. Backyard dwellings, people are trapped by the formal home, the walls, just the structure around. So if I'm here, I've got to get through that home, out the next one. Maybe the door's locked, maybe the windows are blocked. So there's a lot more fatalities per incident, even though the fires aren't as big. You don't normally have 500 homes, 100 homes, 20 homes being affected, but when they do occur, we're getting more deaths, and that's a major problem. And so also another trend is double story. Double story is becoming more common here, and we've run some experiments looking at double story, and what we're seeing is there's a lot more radiation coming from these, so more rapid fire spread, much more difficult suppression, because you struggle to actually get the water through the first floor kill the fire, collapse becomes a major issue. And so this is a major concern for us long term, because it's pushing up population densities, leading to reduced probability of evacuation, much more difficult firefighting operations, much higher risk for firefighters, and generally a major headache. So this will become a problem in coming years. So with that, I'm just going to sort of sum up, because that's, you may have felt those proverbially drinking from the fire hose, a lot of data, and probably maybe a lot of negative, but also I think there is a lot of positive as well, in that as I said, I've focused on the challenges, but often the basic engagements we're seeing with the community, when the community is on board and when the basics are known, it's just phoning the right people, having buckets of water available, making sure that there's water supply, and stopping ignitions from the easily combustible items around the homes. And those sorts of basics that I think people are doing an excellent job. I'm sure your organization is promoting many of these things. And so often those are having a bigger impact than the fancy that people are trying to do. And so this, amongst many other things, are being advocated in the book. So this was a brief introduction. So really, you're welcome, get hold of it, it's free of charge. We will have brochures, etc. soon. And so with that, hopefully that's been useful. And so with that, I think we'll move over to questions. So Nancy, I don't know if we hand over to you at this stage, or what's the way forward.
Yeah, thank you. Wow, that was a lot of fantastic information. I'm going to have Jose help us go through the questions, but one that I see right now to get us started is there was a question about the electrical surge, and I believe what kind of firefighters can do to help with that, and just some more information on that.
Okay, what can be done? Well, firstly, what can cause it? What we are seeing, and unfortunately this is not quantified, there does seem to be more fires occurring. We've got rolling blackouts at the moment, so we don't have enough country, so we get load shedding. So they cut off different parts of the grid at different times of day. And so often after that, when the power comes back, there is a bit of a surge as the system comes online, so that can be a problem. Possibly people also just leaving items on. Our fire cause is very bad. Our fire cause is not accurate. In terms of firefighters, what we are seeing is overloaded plugs, people putting too many devices on plugs, and just to try reduce the how many things are plugged in, and trying to have a bit of a safer layout, promoting safer wiring, and just getting that checked out. And we are busy analyzing some data. We got quite a big database of surveys back, about 2,000 responses. And people identified electrical stoves as a major concern from that. And we think it's also linked to the quality of the stoves people are using. And so electrical is multi-level, because pretty much any electrical item you can buy can cause a fire, but especially the heating, lighting, cooking elements do seem to be causing problems. I don't have decent data, to be perfectly honest. Our fire cause is not where it should be, and simply because it's so difficult to know, what caused the fire. Was it the stove or was it arson? So I'm not blaming the fire department. It's just difficult. And so those are some ideas. But in terms of it, I think also if you have the same thing in your area, try to clear the low-lying cables or formalize them, and just try to get the basics of, try to control the electrical usage, consumption, etc. I'm not sure if that's all, but by all means, you're welcome. This is not a one-way street. I'm sure there's some people that Jose and various others are doing excellent work that can have comments on what you're finding is working. So I'd love to hear from your experiences in other countries as well. But yeah, so that's on the electrical surge. Are there any other questions that people would like to bring up?
Yeah, thanks so much, Professor. Thank you so much for enlightening us on what is going on the ground with the informal settlements. And also in regards to the question that was asked on electrical surges, I usually advocate when I go to my fire sensitization reach outs, I tell the community to use quality wiring, on top of what you said, on top of them having so many wires, so many connections on their appliances, please get to use quality wires that makes it safer, not only for you, but also for the neighbors. Now, I have a question, but before I ask the question, I would encourage, after I ask the question, people may, just as Professor has said, it's not a one-way street. You can get to shoot your questions that are relevant to this lesson today. And going forward, Professor Richard will be able to answer. Now, my question is, you talked about the bucket brigade, which I've found to really be effective in the community that I live in. But then I'm just asking that you said 9 buckets can actually get to extinguish the fire. But I'm just wondering, how big is in your research, how the measurements of of the house, how was it? Was it 10 by 10? Because usually in my community, they give a 10 by 10 feet house dwelling. Yeah, so I don't know, in those 9 buckets that you're talking about, how much was the measurement?
It was I work in meters, sorry, yeah, 10 feet.
Yes.
So yeah, you've got about 3 meters. It's similar. It was 2.4 by 3.6 meters. And it was a timber fuel load. I can't remember if it was 25 or 30 kilograms a square meter of timber we used. I fully agree with you that it depends a lot on what's there. These simple guidelines are more for decision makers that they have a ballpark idea. But especially that was enough cooling to take it from flashover to there's steam in the room, there's no external flaming, there's no fire propagation. It's not guaranteeing that every ember in the room is out, because I think especially with bucket brigades, your risk of reignition is quite high. And especially if you've got cupboards and books and all sorts of things where the fire has slipped into, that might not be enough for mopping up operations. You've stopped it, you've prevented from spreading. Are there embers? Probably. There probably are embers that you will need to then go and mop up with that number of buckets. But it does at least give us sort of a rough ballpark on what we were getting.
Wow, thank you so much.
I'm actually just going to stop sharing and swap over to face so you can rather be a little bit more personal, and I can also see the questions at the side.
Oh, all right. Okay. Thank you. We have a question from Mr. Francis in the chat. He asks, is it okay, let me read it through. Is it okay to demolish a single dwelling if they are construction in a straight line to cut off the spread of fire? That's from Francis.
I think there's 2 parts to answering that, but just as a matter of interest, you might find this fascinating, is dry firefighting methods, for instance, in Japan were used historically quite a lot in the likes of Tokyo and places where they had very flammable dwellings, especially decades ago. And so they would knock down their structures when the fire was coming, and it was fairly effective. So is it okay? It depends on what you mean. Is it okay? Is it legal? I'm not sure of each country. In South Africa, it's very political to knock people's houses down. So historically, it was done in apartheid. They had sort of big military vehicles, and they literally just drive a pathway through and flatten homes. And from a purely fire dynamics perspective, it was sufficient to often cut the spread of the fire, or slow it down at least. But you are destroying people's homes, so it gets a very political challenge. Is it okay in terms of will it slow the fire spread? It depends on a number of factors. It depends on the size of the home. As I said earlier, the radiation can cross between 2 and 5 meters depending on the extent of the radiation and how big what's burning. Flaming brands can blow 5, 10, 50, 20, 100 meters. I mean, we've had fires jump 2.9 kilometers in big fire wind events, not in informal settlements, but in wildfires. And flame impingement is probably 2 to 3 meters. So it may stop it, especially in low wind conditions, a single home, but it depends on the weather conditions, the width that's open, and how what is ignited. So it's not an easy, but it will slow it most probably. Whether it'll stop it, I'm not sure, depending on your situation. I hope that's answered your query.
Yes, I believe Francis has been answered his query. Is there anybody else who would want to ask a question? Please unmute. Professor Richard is ready to answer your question. The floor is yours. Yes, James Kibetsa, go ahead. I can see your hands raised. unmute. I can try help you unmute if you, let me see, ask to unmute. Isa Premji, you'll wait a little bit for James Kibet. James Kibet, go ahead, sir.
Good afternoon, everyone.
Good afternoon, sir.
So much, Professor, for the presentation on fire. I just have a question regarding technological revolution, the structural buildings and material being used, and the current involvement of multi-occupancy behaviors in the current development, where you have maybe high-rise buildings and very complicated or actually new or modern technology buildings. And the involvement of the current status of the fire service in our place. A case study of Kenya, for example, maybe, I don't know your place in South Africa. What is the level of involvement in the fire in terms of policy formulations for building and construction in the municipality, or the involvement of the modern fire towards the modern building technology?
The audio wasn't great, so I'm hoping I didn't miss any of your question. But in summary, if I caught you correctly, the question goes around, especially in South Africa, what is the state of the involvement of modern technology in building safety, especially, I take it, sort of your bigger high rises and the likes, and what's happening now. We do have informal settlements, which are very poor, and we do have very wealthy high-rise buildings being built. The high-rise, we do have a number of fairly competent fire engineers, but not a lot. And so the more advanced buildings are using more advanced technologies. We do have codes of practice, SANS 10400, but our codes of practice are somewhat behind at the moment. So often they are adopting international codes of practice when using those, whether they're British, European, NFPA, etc. And the fire services, it depends on what extent they're involved. In Cape Town, we actually have quite an active fire protection type group looking at modern construction systems. So even if you're looking high-rise timber, they will then get involved and they will evaluate whether it is all the different systems. So it is coming. It is a long way behind, for instance, Europe and America, but there is a certain amount of willingness, especially on the upper end income type projects. I'm not sure if I captured everything with the audio, but possibly that's answered your question. If not, feel free to pop it in the questions at the side in the chat box.
Mm-hmm. Thank you so much, Professor. Isa Premji, you had your question. Could you please shoot it? The floor is yours, sir. Isa Premji.
Thank you, Ngujiri. Mine is not a question, it's just adding to Francis Joroge. So I think in Nairobi, we don't have a problem in demolishing people's houses if to stop the fire, because we had the fire in Gikomba, we did the same thing, and we had a fire at Deep Sea, which we had to demolish a few houses for the fire not to spread out. Okay. So that was just to add on to Francis Njoroge's. Okay. And I guess Gunjiri, you can confirm that one.
Yes, just to confirm with what Mr. Isa Premji has said, there's actually usually, before the actual demolition, the communities are sat down and they are told, hey, if there is fire, we might actually destroy your home, not really destroy, we might break your homes so that it doesn't spread, okay? And those houses that are broken down, they will be included in the count as if they were burned. Okay. Yeah, so when it comes to either compensation or something like that, they are already informed by the administration. And here in Kenya, we have, after every 10 households, there's one person to administer those 10 households. So that 10 household administrator is responsible to say, yes, my houses were flattened out and we need compensation, something like that. If there's any compensation that might be there. So I confirm what Isa Premji has said.
Okay, thanks for that.
Gunjiri, just to add sorry about that. Gujiri, just to add to that one, yes, compensation is there because part of the Red Cross team that goes around and part of the MCAs or whoever well-wishers will come in will always confirm that the house that we have demolished is part of the count, right? That we have allocated, that they have, whatever is going to be allocated, that house will be part of the count or whatever they're going to get from the well-wishers, Red Cross, MCAs, and whoever comes upon to help.
Professor Richard, MCAs are members of the county assembly. So that's just a short form of the MCA.
Okay.
Yeah.
Just as sorry, go for it,
I'm going
Nancy.
to interrupt just for a moment. I want to just acknowledge the time, but also and you are all welcome to continue the conversation. We'll continue the conversation, but I do want to wrap up the formal part of our training here and just say thank you, Professor, for contributing today. I know this was so much fantastic information. We will have all of the links on our website within the next 24 hours for you all. So please reference those. We'll also post those in AFM's networking group so you can see those. I know this will be information you'll want to share with your colleagues and continue to press that information forward. So thank you very much for today's training.